Hello, welcome to Gears by A Posteriori. We're really excited and very proud to present this new robotics education tool. My co-founder and partner, Court Wee, was so busy during lockdowns of the COVID-19 epidemic and managed in a month or so to create the basis for a brand new platform for robotics, virtual robotics, and coding education. And this is an expansive platform. It's all open source. We're hoping that you can use this in your classrooms and in your work or in your educational journey to learn a little bit about robotics and a lot about coding and how to how coding works in a robotics from a robotics point of view. So I wanted to use this time to present to you with a lot of the different features of our platform and just to give you a basic orientation. From there, we will start a set of tutorials to teach you how to go through a bunch of the worlds that we've created already for people to use. But by no means is any of this restrictive from the environment's perspective, because you can design your own robots and your own worlds using our platform. Well, let's get started. When you first bring up gears.aposteriori.com.sg, you will see this particular What's New panel. This panel will contain information about what's new in our platform since the last time you brought it up with cookies or cache in your environment. So when you move to another computer or to another browser, or if you delete your cache and cookies, obviously we won't know if you had used it before, so you'll see this panel again. It'll have some information about new major features that we've added to the system. Okay, let's go down, click OK. And once you are out of the What's New panel, or the next time you come into Gears world, you will see this area, which is our blocks coding panel. It has a bunch of tabs with a bunch of coding blocks. If you're familiar with block programming, you will have seen something similar to this in the past. This is based off of Blockly, and so if you've seen anything else based off of Blockly, you would have seen this sort of structure of blocks. If you're more familiar with Scratch or another type of platform, maybe you've seen a slightly different style of the same basic configuration, where you have tabs. The tabs have some category. Once you open them, you have blocks. The blocks can be dragged out, connected to one another, and you can change aspects of the blocks inside of them. We also have a Python panel. The code of the Python panel gets automatically generated. It uses, as you can see, EV3Dev, the EV3Dev library bindings. So we already have a lot of our robots' ability to sense and to move already set up using that, and any new things we create or you create, we need to bind to an extension of this library, and I'll talk to you about some of those, like our laser sensor, etc. If you make changes inside the blocks, for instance, if we add a move tank with speed 20% on both sides, we will see a tank drive line, a parallel line in the Python code. However, if I start typing in my Python panel, we'll get a warning that the Python code is not being converted. This is a limitation of our system at this time. So if you ever want to go back to blocks, you will need to lose all of the code that you've done in Python. But if you're happy with a Python-only environment, feel free to code directly in Python. I'll be showing mostly tutorials using block programming, but by no means should you be limited to using block programming on your end. The simulator is the environment where we have our robot, and how we test our code and how we make our code come to life. So there's a lot going on here. I'll get back to it in a second. There are ways for you to save your blocks or save your Python code locally on your computer and then load them back in. There's a few other things you can do, like importing functions and zipping packages of the world and the robot together. And if you want to start from scratch, you can click on New Program, and once you go back to your Python or blocks, you'll see that we no longer have that motion block that we added before. For Python, we have a few modes. You can use the EV3 dev mode. There is a Pybricks mode that makes the Python code bind to it, but it doesn't currently work with live simulation. So for now, I recommend keeping it on EV3 dev mode. We also have this robot menu. In it, we can select different robots. So we have robots that are configured for particular functions. This is a single sensor line follower with one color sensor pointing down, but we also have a double sensor line follower where there would be two color sensors. There are also different robots for different scenarios. We have some paintball-based scenarios. We have a maze scenario where maybe ultrasonic sensors on 3 sides make it a lot better. There are tow trucks with different actuators and crane with a different type of actuator. And you can also design your own robot under robot configurator. You can use the robot configurator to change the robot's body height, its width, its length, and wheel diameters, wheel width. You could configure the base robot based on these things. You can add different sensors and different actuators that we've already designed. You can play around with this. There are a bunch of ideas that we're still experimenting with, and we'd love to hear your ideas as well. Okay, once you've created your robot, you can save it, and then you can load one from the file, and you will be able to load it as your main robot in the normal Gears world. So I'll go back now to my safe zone here, and experimenting with robot configuration is not what I'm going to cover today. But another thing I wanted to show you is once you've selected your robot, the description will allow you to see the EV3 bindings for the different actuators and sensors. So importantly, we have ports A, B, C, D, the letter ports for our actuators. In this case, A and B are the left and right wheel, and C is an electromagnet on the bottom of this robot. I'll show you now once we get back to the simulator. And we have 4 sensors, the one color sensor that I mentioned already, but also an ultrasonic sensor on top, as well as a gyro sensor and a GPS. Not all of these have direct bindings to the basic EV3 Lego kit, but these are based in, all of our sensors and actuators are based on some vision of a realistic kind of component. Okay, let's see what we have. Anything else? The arena, again, it's a pretty new feature for us. If I go to the arena, it will allow me to load multiple robots in there. So once you've created your robot and robot code for that robot, you can package those up and go to the arena and maybe play with multiple robots at the same time. I'm not going to cover that today, but I think it's one of the coolest features that we've added recently and kind of separates us apart from many other simulators at this time. Back to the simulator. So we have the robot that we've selected. Now we can also select different worlds. So since we're doing line following, I might want to choose the line following world, but we have a lot of other different types of worlds. worlds for practicing how to do to use the gyro to go in a straight line. We have worlds for testing paintball launcher. We have worlds for simulating some kind of a sumo challenge. We have worlds for simulating something along the line of maybe Coast Space Rescue, where you have some shapes to pick up from the floor, and maybe a timed challenge. We have a maze world where you can select different mazes and even create your own. And we have an ability to generate worlds from flat images and maybe add a bunch of add all kinds of items and bits into those worlds. So, for instance, if you cared about FLL, you have the FLL map. There are no models on top of the map. You'd need to configure those yourselves and create them. But at least we have the basics for for the lines that you can follow on this map. And a new kind of cool tool that we added was the ruler recently, and you can use the ruler to maybe figure out how far your robot needs to travel between 2 points on this flat map. Okay, back to our world selection. I'm now going to put us back to line following world, and I will start with the simple curves, but we have a lot of different challenges here, going from the easiest at the beginning to the hardest at the end. I'm just going to go for simple curves. There's a brief description of it. You can tell your robot to start at different places than the default, but for now let's just start where we start and close our little ruler tool, and we can see that we have a tabletop with some line drawn on it. Pretty simple, white space, black line, not a lot to talk about here. What I can talk about is we have different camera views, and the way I'm rotating right now is I'm holding either the left or right button under this camera view. This is the follow camera view. When we use the follow camera view, we're always from the perspective of the robot itself, so the robot is always at the center of the viewport. And when we zoom in, we can zoom in directly into our robot, and we can look underneath. You can see it's two wheels. The basic robot has two wheels on either side of the front of the robot, and ball bearing on the back. And there's, in this particular case, there's an electromagnet on the bottom towards the center of the robot. That's its third actuator that we saw before. So that's one particular camera view. You can also use the top view. Once you're in top view, though, you can immediately change the perspective. Just note that now the center of the viewport is not necessarily the robot anymore. And there's a further view for you to test, which is the arc view, and it'll have slightly different limitations and capabilities. In all of these cases, you can test how to zoom, how to rotate, and how to pan. In some cases you're allowed to pan, and the panning might require different button presses, shift or control together with the other buttons, or you might be able to pan with one button and on the top level view I believe left button pans and right button rotates, whereas in the arc it might be different, and there's no panning in follow mode because you can't pan away from the robot being in the center of the viewport. So I just want you to play along with that and try to see underneath the robot, try to see over the robot, try to see from up close, etc. Do different things to try to view what you want to see. And at the end, what's the most important thing that I wanted to cover here is that we can see that the robot is situated right over the line. The line is right at the center, and the color sensor, which is at the center in the front of the robot, is pointing directly at the line. And our sensors panel, which my head is blocking a little bit, our sensors panel allows you to see the different readings from whatever sensors are currently on top of this robot. The color sensor, which we're going to use for line following, shows us red, green, and blue intensity, but also the intensity of the reflective light back into the color sensor itself. So we can see that the color intensity is only 2% because the robot is situated right over the line. Well, the color sensor is situated right over the line. So the color that's reflected back at the color sensor is of low intensity because most of it is absorbed by the black color. We can also see the ultrasonic sensor, which is pointing directly at me right now, but doesn't see me. It sees the world, and it can see nothing, so in front of it. And just like in EV3, the maximum distance that we can get a reading for is 255 centimeters. Our gyro is this sensor here, up here, and as our robot rotates towards the left or right on this XY axis, you will get different readings from this gyro. The GPS sensor, again, maybe not common to EV3 world per se, but common in, you know, the world of robotics automation, having something like a GPS sensor that tells you where you are in the world with respect to some coordinate system. In our case, you know, we have an XY coordinate system where X is this axis, so we're in the middle of the X-axis at this point, and we're further back on the Y-axis, which is the length of the table. The 0 is maybe in the middle of the table, so we'll fall off the table when we reach maybe around 90 or 100 centimeters on the other side. The altitude would be where we are on the Z-axis, which we can assume is a line perpendicular to the table itself, you know, going up through and down through the table. And then we have position and degrees of the left and right motors, so we can assume the same kind of encoding sensing of rotation of these motors that we have in the EV3 motors as well. I'm just going to remove my head for a second so I can show you the position in degrees of either the left or right motor at the end. And those are basically readouts of the encoders that you might have in an EV3 large or medium motor that show you how far the robot had, the motor had rotated in either direction. Okay, so those are our sensors in the sensor tab. Of course, if you have different sensors set up, then you might see different readings in the sensors tab. We'll cover that in a different challenge. And that's about it for what we can do with the basics of and that's about what we can do in basic, you know, from a basics overview perspective. This is what you can do with the Gears world. It's super rich. I've shown you just a little bit of how to manipulate some of the things, some of the basic features, but I haven't really shown you how to customize and extend any of these things. It's an open platform. It's an open source platform, so we are constantly improving it, and we have partners who are helping us to improve it possibly in the future. And we invite you as well to try to help us develop it further. Just as a beginning, for the next few tutorials, I'll be doing line following using this platform, teaching you the line following algorithms. And just as a starting point, I just want you to be able to move your robot around this field. So, we've talked about everything except this play button. And right now the play button doesn't do anything because my blocks haven't been, I haven't created a program to do anything. So let's try to do that now. To move the robot, you have a choice of either moving one motor at a time, so you can run either A or B to be able to move the wheels. You can also, on this robot, run motor C, which would start the electromagnet. There's going to be some wiki area where you can find out how to do that and what percentage speeds you would need to get your electromagnet to work. But for our intent and purpose, since we are moving a simple two-wheeled robot, we usually use either a tank or a steering type of block, similar to the EB3. Again, there's a binding from the EB3 dev library to the same types of blocks. In this case, you can control the speed of either left or right wheels. And in the move steering block, you can control, how far to the left or to the right do you want to be turning, or how straight you want to be going, and at what speed. For line following, I prefer to use the tank blocks, but you feel free to choose either or. For now, let's just make our robot go forward. And in this particular case, we're telling our robot to go forward until further notice. So there's no how much to go forward for. You can use the blocks to tell it to go one rotation of each wheel, or for a particular number of degrees or seconds or milliseconds. But for now, let's just try to get our robot to move forward until further notice. And we can see that it's doing just that. The program already finished execution and left and exited, but since the wheels have never been told to do anything other than continue to moving, they're continuing to move, and we'll see eventually it'll fall off the edge and plummet. One of the beautiful things of virtual robotics is that we don't have to worry about parts breaking or losing any Lego pieces that fall off and explode into a lot of different places of the room. So luckily we can just click reset and we have our robot back on our table. We will be doing something with the line. So as we noted before, the intensity of the sensor is fairly low when we're on the line, but when we're moving forward, we can see that the intensity goes up to 100% when we're all over white, and it goes back down when it goes back on the top of the line and goes back up to 100, etc. For our first challenge, let's just try to get the robot to stop once it's over the white area. So whenever you see intensity is 100%, stop the robot. I will pause at this point and I will let you test that, and I will come back with a solution for that. But feel free to not move on to the next video and do this on your own. You're at gears.aposteriori.com.sg. It's the Gears platform brought to you by Aposteriori, and we welcome you to this new world of robotics with us.